Imagine this. One clear night, you look up at a sky you have seen 1,000 times before, and there, among the familiar stars, is a new one. A star so bright you have never seen anything like it. Bright enough to cast a shadow. Bright enough to see in the middle of the day. What would you think? People long ago actually saw this. A brilliant new star that blazed for weeks, and then slowly faded away. But here's the twist. It was not a star being born. It was the exact opposite. It was a single star tearing itself apart in the final moment of its life. This is a supernova, the most violent and strangely the most beautiful death in the entire universe. Tonight, we are going to find out how a star reaches such a spectacular end, why it explodes with the force of 1 billion suns, and along the way, we will uncover something almost unbelievable, that this violent death, happening in a star trillions of miles away, is the reason you are alive right now. So let's start with a mystery that puzzled our ancestors for thousands of years. The word supernova comes from Latin. Nova means new, which is a little bit funny, because a supernova is not a new star at all. It is a dying one. The name stuck because, to the people who first saw it, a star had appeared where there was nothing before. Honestly, it might be the worst named object in all of astronomy. It is the grand finale, wearing a name tag that says, "Hello, I'm new here." Humans have been watching these events for a very long time. Ancient Chinese astronomers called them guest stars, stars that showed up out of nowhere, stayed a while, and then quietly left. The most famous guest arrived in the year 1054. It was so bright it was visible in broad daylight for 3 weeks, and records survive from China, Japan, and the Middle East. And the glowing wreckage of that explosion is still out there today. We call it the Crab Nebula. When you look at it through a telescope, you are looking at the aftermath of a light that first reached Earth nearly 1,000 years ago. And that one was not even the brightest. The most dazzling supernova in all of recorded history appeared in the year 1006. It blazed so fiercely that observers across the world wrote that you could read by its light in the dark. It hung in the sky for months. Picture that. A single point of light, so brilliant it turns the middle of the night into something like a silvery dusk. That is the raw power we are about to explain. So why does a star die like this in the first place? To understand a supernova, you first need to understand that a star spends its whole life in a tug-of-war. On one side is gravity, constantly trying to crush the star inward under its own enormous weight. On the other side is the heat and pressure from nuclear fusion in the core, pushing outward. As long as these two forces are balanced, the star stays perfectly round, calm, and shining. It is a standoff that can last billions of years. Our sun is winning this tug-of-war very comfortably. It quietly fuses hydrogen into helium in its core, and it will keep doing that for about 10 billion years. Slow and steady, no drama. The sun is the kind of star that will simply grow old, puff up, and gently fade. It will never explode as a supernova. For that, you need something much, much bigger. The stars that go supernova are the giants. Stars at least 8 times heavier than the sun, and these giants live fast and die young. You might think a bigger star, with more fuel, would live longer. But it is the opposite. A massive star burns through its fuel so recklessly that it lasts only a few million years, instead of billions. In the world of stars, the biggest are the reckless ones. They live like rock stars, and they go out like rock stars. Here is how a giant star spends its final chapter. When it runs out of hydrogen in the core, it does not just quit. It starts fusing the leftover helium into carbon. When the helium runs out, it burns the carbon into oxygen. Then oxygen into neon, neon into silicon, each fuel heavier than the last. The star becomes desperate, switching to a new fuel every time the old one runs dry. And this builds up a remarkable structure inside the star. Layer upon layer of different elements, wrapped around each other like the layers of an onion. Hydrogen on the outside, then helium, then carbon, oxygen, neon, and silicon, sinking deeper and hotter toward the center. Each layer is a furnace, burning a different fuel. The star is now a cosmic onion, and it is running out of options. And here is the part that gives me chills, because it shows just how close to the edge this giant is now living. Burning hydrogen keeps the star alive for millions of years. Burning helium lasts only a few 100,000. Carbon buys it a few 100 years. Neon and oxygen, about a year. And that final layer, silicon fusing into iron, the star burns through in roughly a single day. Let that sink in. A star that shone for millions of years lives its very last day, fusing silicon, with absolutely no idea that tomorrow it dies. Because that silicon is fusing into iron, and iron is a wall this process cannot cross. It is a final element the star can build, but can never burn. Iron is the beginning of the end. To see why, we have to understand exactly what nuclear fusion has been doing this whole time. Every fusion reaction so far has done the same helpful thing. Fuse two light elements together, and energy comes pouring out. That released energy is what heats the core and pushes back against gravity. It is the star's entire source of power. Hydrogen gives energy. Helium gives energy. Carbon, oxygen, silicon, all the way up. Each one releases energy when it fuses, until you reach iron. Iron is the most stable element in the universe, and that stability comes at a terrible price for the star. If you try to fuse iron, it does not release energy. It swallows energy. Fusing iron actually takes power away from the core. So the moment iron piles up in the center, the star's furnace doesn't just slow down. It shuts off completely. The engine that has been fighting gravity for millions of years suddenly has no fuel left to burn. And now, remember the tug-of-war. For millions of years, the outward push has held gravity back. In an instant, that outward push vanishes. There is nothing left to hold the star up. So gravity, which has been waiting patiently this entire time, finally wins. And it wins fast. The core of the star, an iron ball larger than the Earth, collapses in on itself. And this is not a slow settling. The core falls inward at up to a quarter of the speed of light. Something the size of our whole planet is crushed down to the size of a city in less than a single second. It is the most violent break in the universe. A star that lived for millions of years decides its fate in a fraction of a heartbeat. The collapsing core crushes down until it simply cannot be crushed any further. The particles inside are jammed together as tightly as the laws of physics allow, forming a core so hard and so dense that it suddenly stops dead. And the outer layers of the star, still crashing down at incredible speed, slam into that unyielding core and bounce. That rebound launches a monstrous shockwave, racing outward through the star and blasting everything above it into space. This is the explosion. This is a Type II supernova, a core collapse supernova. In a few seconds, the star releases more energy than our sun will produce in its entire 10 billion year lifetime. For a few weeks, this single dying star can outshine an entire galaxy of 100 billion stars. Let that sink in for a second. One star, briefly outshining 100 billion others combined. If our nearest bright star went supernova, it would blaze in our daytime sky like a second, smaller sun and glow for weeks before slowly fading. Every supernova you have ever seen in a photograph is not a whole galaxy lighting up. It is a single dot. One star, screaming louder than everything around it, all at once. And here is a strange detail that took scientists by surprise. Most of that colossal energy does not leave as light or heat. It leaves as tiny, ghostly particles called neutrinos. So many neutrinos pour out in those few seconds that they carry away the vast majority of the explosion's power. They are the star's true final scream, and almost all of it is invisible. In 1987, a star exploded in a nearby galaxy, and a detector deep underground in Japan, called Kamiokande, caught a handful of those neutrinos as they passed through the Earth. Just a couple dozen particles from an explosion over 100,000 light-years away. It was the first time humanity ever detected a supernova by something other than its light, and it later earned a Nobel Prize. We heard a star die from the bottom of a mine. Now, there is a second, completely different way for a star to go supernova. And this one does not involve a giant at all. It starts with the quiet leftover of a small star, like our sun. When a star like the sun dies, it does not explode. It gently sheds its outer layers and leaves behind a small, incredibly dense core called a white dwarf. Picture something the size of the Earth, packed with the mass of the entire sun. Normally, a white dwarf just sits there and slowly cools down over billions of years. A calm, dim ember, the end of a peaceful life. But things change if that white dwarf is not alone. Many stars come in pairs, orbiting each other. And if a white dwarf has a living companion star right next to it, the story takes a dark turn. The white dwarf begins to steal. Its gravity pulls a steady stream of gas off its companion, and pile by pile, it grows heavier. It is the opposite of a diet. This little ember sits there, quietly fattening itself up on stolen material from the star next door, getting closer and closer to a critical limit. That limit is about 1.4 times the mass of the Sun. Astronomers call it the Chandrasekhar limit, and it is an absolute line in the sand. The instant a white dwarf crosses it, it can no longer hold itself up. A runaway wave of fusion tears through the entire star in seconds, and it detonates completely. Nothing is left behind. This is a Type 1a supernova. And here is where it gets beautiful. Because every Type 1a supernova explodes at that same magic weight, they all blaze with almost exactly the same true brightness. Think about what that means. If you know the real brightness of something, and you measure how bright it looks from far away, you can calculate exactly how far away it is. A dimmer one is simply farther. A supernova becomes a cosmic measuring stick. Astronomers call these explosions standard candles, and they use them to measure distances to galaxies billions of light years away. What they found rewrote our understanding of everything. The universe is not just expanding. Its expansion is speeding up, pushed by a mysterious something we now call dark energy. That discovery won the Nobel Prize. Think about that. The death of a single star became the ruler we use to measure the fate of the entire cosmos. So we have two roads to a supernova: a giant star collapsing under its own iron core, and a white dwarf stealing itself to death. Two completely different stories, ending in the same blinding flash. But no matter which road a star takes, the explosion does something that changes the universe forever. And this is the part one I've been waiting to tell you. A supernova is not just a star dying in style. It is one of the most important factories in the entire universe. To see why, we have to go all the way back to the beginning of everything. Right after the Big Bang, the universe was almost unbelievably simple. It was basically just hydrogen and helium, the two lightest elements, and nothing else. No carbon, no oxygen, no iron, no gold. None of the rich variety of stuff that makes up planets and people. So the obvious question is, where did everything else come from? Where were all the other elements made? The answer is, inside stars, and in their explosive deaths. During its life, a star fuses hydrogen and helium into heavier elements like carbon and oxygen, the very building blocks of life. And then, in the unimaginable heat and pressure of a supernova blast, even heavier elements are forged in an instant. Gold, silver, and much of what lies beyond iron on the periodic table. And here is the crucial part. The supernova does not keep all of this treasure. It blasts it out into space, seeding the galaxy with every element it just made. Those elements drift through space for millions of years, mix into new clouds of gas, and eventually collapse into new stars, new planets, and yes, new living things. In fact, a supernova does not just supply the ingredients for new stars. It can actually trigger their birth. When that shockwave slams into a nearby cloud of gas and dust, it squeezes the cloud, and that squeeze can be exactly the push it needs to start collapsing into brand new stars. So a dying star, in its final explosion, plants the seeds of the next generation. There is a good chance our own sun was born this way, nudged into existence by the death of a star that came before it. And there is one more twist that scientists only confirmed recently. Some of the heaviest elements of all, like much of the gold and platinum in the universe, may come from an even rarer event, when two leftover neutron stars spiral together and collide. In 2017, telescopes and gravity wave detectors caught exactly such a crash and watched it fling out a cloud of freshly made gold, worth more than entire planets. The universe, it turns out, has more than one way to make treasure out of a stellar death. But let's come back to you. The iron in your blood, right now, carrying oxygen through your body. The calcium in your bones. The oxygen you just breathed in. Every single one of those atoms was forged inside a star and scattered across space by a stellar explosion long before the Earth even existed. So this is not poetry. It is not a metaphor. It is literal, physical fact. You are made of the ashes of dead stars. You are a supernova, walking around, thinking about supernovas, which, honestly, is such a beautiful idea that next time a doctor tells you your iron is a little low, you are fully entitled to say, "Sorry, my supernova ran a bit short on stock." The astronomer Carl Sagan once said it perfectly. We are made of star stuff. When he said that, he was not being romantic. He was describing exactly how atoms travel from the heart of a dying star into the ground beneath your feet and into the cells of your body. Every atom heavier than helium, everywhere around you, is a little souvenir from a star that died so that you could exist. So the star has exploded and scattered its riches across the galaxy. But what happens to that ultra-dense core that was left in the very center? What remains after the fireworks fade? That depends entirely on how heavy the original star was. If the star was, say, 8 to 20 times the mass of the Sun, the crushed core becomes a neutron star. This is one of the strangest objects in existence. It packs more mass than our Sun into a ball just a dozen miles across. A single spoonful of neutron star would weigh as much as a mountain. It is matter squeezed almost beyond belief. Some of these neutron stars spin incredibly fast, hundreds of times a second, firing out beams of radio waves as they whirl. From Earth, we see those beams flash past us with astonishing regularity, like a cosmic lighthouse. We call them pulsars. In fact, there is one sitting right in the heart of the Crab Nebula, the ghost of that guest star from 1,000 years ago, still spinning 30 times every second. But if the original star was truly enormous, far more than 20 times the mass of the Sun, then not even a neutron star can hold the line. Nothing can stop the collapse. The core keeps falling in on itself, past every limit, until it forms an object so dense that not even light can escape its grip. In that moment, a black hole is born. Now, neutron stars and black holes are so bizarre, so mind-bending, that they each deserve an entire story of their own. And that is exactly what we will do next time. So for tonight, let's leave those two strange ghosts glowing in the dark and come back to our own sky. Supernovae are rare. In a galaxy like our Milky Way, one only goes off, on average, every 50 to 100 years. That rarity is exactly why the ones we can see with the naked eye were burned into human history. The Crab in 1054, Tycho's star in 1572, which shattered the old belief that the heavens never change. Kepler's star in 1604. The closest one in modern times was that star in 1987, the same one Kamiokande felt. For the first time, Astronomers could point their most powerful telescopes at a fresh supernova and watch it unfold day by day in a nearby galaxy. It confirmed, in real time, much of what we had only worked out on paper. But even that one was over 100,000 light years away. In our own galaxy, we have not seen one with the naked eye for a very long time. And here is something that makes astronomers just a little bit restless. That star in 1604, Kepler's star, was the last supernova anyone saw with the naked eye in our own galaxy. That was over 400 years ago. Statistically, in a galaxy our size, we are well overdue. Somewhere out there, a star may already have exploded, and its light is simply still on the way. And there is one very famous candidate. Look up at the constellation Orion in winter and find the bright reddish star marking his shoulder. That is Betelgeuse. It is a red supergiant, hundreds of times wider than our sun, and it is very near the end of its life. When it finally goes, it will blaze in our sky for weeks, bright enough to see in daylight, casting shadows at night. A few years ago, Betelgeuse gave everyone a scare. Over the winter of 2019, it suddenly dimmed, dropping to a fraction of its usual brightness. Astronomers around the world held their breath, wondering if we were about to watch it blow. In the end, it turned out to be a giant cloud of dust the star had coughed out, temporarily blocking its light. A false alarm, but it was a thrilling reminder that this star is genuinely on the edge. So, is Betelgeuse about to explode? Well, near is a funny word in astronomy. It could go tonight, or it could hold on for another 100,000 years. Nobody knows. But do not worry. Betelgeuse sits about 640 light years away, far too distant to do us any harm. If it explodes, it will simply be the greatest light show of your lifetime. A perfectly safe front row seat to a dying star. And here is a mind-bending thought to end on. Because Betelgeuse is 640 light years away, its light takes 640 years to reach us. So if you looked up tonight and saw it explode, you would not be seeing something that just happened. You would be seeing light that left the star centuries ago. In truth, Betelgeuse might have already exploded hundreds of years ago, and the news simply hasn't arrived yet. The cosmic mail is always running late. From a mysterious guest star, to the iron wall, to the atoms inside your own body. That is the story of the supernova, the most destructive event we know of, and yet, without it, none of this, not the planets, not you, not a single living thing, would exist at all. Destruction and creation turn out to be the very same moment. Here is tonight's one question. What role does a supernova play for the rest of the universe? 1. It keeps stars from crashing into each other. 2. It forges heavy elements like gold and silver and scatters them across space. Or 3. It makes black holes disappear. The answer is 2. In the extreme heat and pressure of the blast, a supernova forges elements heavier than iron and then flings them out across the galaxy. The gold in a wedding ring on someone's finger may have been made in a star that exploded billions of years ago. A star's death, resting in the palm of your hand. Doesn't that change the way you look at the night sky just a little? And that brings us to the end of today's story about the supernova, a star's most violent death, and yet somehow, it turned out to be the very thing that builds new life and builds you. Destruction and creation, sitting this close together. The universe really is a strange and wonderful place. So here's my question for you. Would you want to witness a supernova with your own eyes just once in your life? If a new star ever appears in your night sky, remember, it is really a final letter sent from a dying star. Thank you so much for watching all the way to the end. If you had fun or you learned something new today, please consider subscribing. Next time, we will step into the world of the strange objects the explosion leaves behind, the neutron star and the black hole. So, until next time, I will see you in another world.